Bandwidth for changelog is provided by Fastly. Learn more at fastly.com, and we're hosted on Linode servers. Head to linode.com/changelog. This episode of JS Party is brought to you by Hired. Hired matches outstanding people with the world's most innovative companies. At Hired, your dream job is waiting to apply to you. Instead of endlessly applying to companies hoping for the best, Hired puts you in control of when and how you connect with interesting opportunities. The best part is Hired is completely free to you. It won't cost you anything. In fact, they pay you to get hired. Head to hired.com/JSParty. Don't Google it. This URL is the only way to double the hiring bonus to $600. Once again, hired.com/JSParty. And now onto the show. Welcome to JS Party, a weekly celebration of JavaScript and the web. Tune in live on Fridays at 3 p.m. US Eastern at changelog.com/live. Join the community and Slack with us in real time. Head to changelog.com/community. Follow us on Twitter. We're at JSPartyFM. And now on to the show.
Hey everybody, welcome to JS Party, where it's a party every week with JavaScript. We've got a special guest today. Say hello to John-David Dalton, also known as JDD.
Hi. That's me. I'm JDD.
I'm Mikeal Rogers.
And I'm Alex Sexton.
And today we're going to dive into ES modules. So to kick us off, I want to get into the history of ES modules because I listened to this terrible podcast in the JS Party feed where jQuery took over and Paul Irish made some interesting statements about how the node modules did it wrong and how, why do, ES modules have to be .mjs if they're the ones that suck, which...
That was my line.
Yeah. Yes. Okay. Yeah, that was your line. Yeah. So the problem. Yeah. That kind of argument works if history doesn't matter.
Oh no. I mean, I think if you listen, I think we understand the situation. It was just kind of a fun time to use the "he's the one who sucks" line from
Right.
Office Space. Cool.
Right. But when I listened to that in my headphones, I was screaming because I was like, we couldn't have done anything at the time because ES modules didn't exist. So we were joking earlier that we're highly qualified to do this because Alex wrote 2 sentences of the AMD spec, and I wrote one sentence of I wrote one sentence of a revision to the CommonJS spec. So we're well qualified.
I mean, I can't think of people who would have written more than that.
I write code that supports both. Yeah.
So to really go as far back as we can, JavaScript is like a thing that you script include in your page. It's been that way for a long time. First people to do everything are usually Dojo. They do it in this way that everybody ends up hating, but yes. Dojo really did do modules first. They had, an independent loader where you could really isolate your code and write your own stuff. And this was way before, source maps. So in order to get line numbers while you're debugging, you really did have to do the async loading stuff. So they had this whole async loading system for debugging. They had a giant Java toolchain for actually bundling everything together before people really bundled their code like that.
At first, it was all synchronous, right? Yeah, like it literally used synchronous AJAX and eval.
Oh yeah, that's right. It was synchronous XHR.
It would take like 3 minutes for your app to boot, and then that's kind of where I am. So, he's one of my favorite people in the entire world. James wrote AMD. Oh my goodness. This is
James. Oh man.
Require JS.
GitHub.
Yeah. Oh my goodness.
I'm doing the same thing.
He's seriously J.R. Burke, James Burke. That's what it is. Okay,
yeah, there we go.
James Burke was on the Dojo team, so AMD actually kind of came out of Dojo a little bit.
Oh, that's cool.
And then like was the official loader once the Require.js kind of started to exist. But there was like the first synchronous loader, and then there was the asynchronous version of that, and then that kind of turned into the AMD spec. So like even stuff we still kind of at least deal with today. I don't know too many people still using AMD, but it all comes from that original Dojo stuff, like very directly.
Mm-hmm. So before we get into AMD, though, I think that we do need to rewind a little bit. So sort of, I don't think that they really looked at Dojo at all when they did this, but there was this early server.js community where people were, building a JavaScript platform for the back end. The primary one at the time was one called Narwhal, which was on the JVM. And these were really dominant before kind of Node came around. And there were a lot of people, thinking about different ways to build out this backend. The one interesting thing about Narwhal, though, was that it did have a lot of synchronous I/O patterns inside of it. So their module system was synchronous, and even though it had to do file I/O and all that kind of stuff. So they didn't do an async loader at all because it didn't really matter to them. And so they wrote this really simple module pattern.
Did it use load?
No, I'd have to ask Chris Colwell. I'd have to ask Chris Colwell to make sure, but I don't think so.
Okay.
But this was like the first, I think, more kind of formalized spec for how you could write JavaScript modules. The traditional Node.js module users have seen this pattern. It's very similar. The big difference that I would note that is very important is that the module.exports equals a function. That whole pattern where a module could just be one function, that didn't exist in the CommonJS spec.
Correct.
That was something that got added later. And so a lot of people started using the spec in the Narwhal space. And when Node.js started, it grabbed that spec. Also, CouchDB, I think still to this day, has CommonJS module support. So you can, add them into properties on a view. And then in your view, you can actually use CommonJS modules. So the spec kind of got around and people started using it for modules and stuff like that. But eventually, Node just became so popular that the server.js effort kind of died off. And a lot of, and Node started to make some very Node-specific adjustments to the module system. So it's really not compliant in any way with any spec that the CommonJS wrote. It's not just that module.exports equals a function thing. There's a lot of other stuff in there about how the resolution works inside of Node_modules and all these other little tricky things that really matter when you start to say, oh, let's add another module spec. But a lot of people didn't like this module system, including James Burke. They felt like it was not quite fit for the web because it didn't have this async loader, because it wasn't built around that stuff. And so that's where
they were objectively right?
Yeah, I mean, it's synchronous versus asynchronous. So the web, synchronous on the web is not great.
Well, I mean, synchronous in Node is also not a thing. But with Node, what we figured out was that even though everything in Node is async, it actually makes sense to have a sync module system because you need to load up your entire application before you can
only
actually
makes sense
handle
on the
things.
server.
Right. Yes. Okay. Yes. That is fair. But what people were doing already with Browserify was they were taking a bunch of these modules and bundling them up and using them in their web applications. And everybody in production, even if you're using AMD, ends up doing this bundle step. It's really only in debugging where you want to truly asynchronously load these things, right?
And potentially in the HTTP2 push future, but
yeah. I've seen some interesting benchmarks around that that show that it's still not.
I think we're far away from that, but yeah, it's some theoretical future where it's just as fast to not bundle.
Right. And so, so the AMD spec comes along. It had a lot of good fans, people that really liked it.
It was actually part of CommonJS as well.
Yeah, so
it was a CommonJS spec.
Yep. So they went back to CommonJS, and so when we talk about server.js and the CommonJS community, this was a mailing list. Like, it wasn't an official standards body. It was really like a mailing list of people that argued about specs that they were writing on a wiki. Nice. There wasn't much of a process, and that I think AMD passed without too much turmoil. But when they started to try and define promises, they got into a lot of trouble. Yeah. Because people just could not agree. And so they ended up with, I think, 5 specs or something. Anyway, so that kind of brings us to ES modules, right? So I think ES4 had a module spec in it, which, ES4 kind of died off. And then there was still, though, like a spec kind of floating around that was very much based on Python, very, very Pythonic. And that had some really kind of like some anti-patterns in it that we really advocated against in Node. For instance, like the import star from something. Have you ever seen this? Where in you can do this in Python and a few other module systems where you basically say, every property in this module, just dump it into the current namespace with that name. It seems really convenient, but it makes it impossible to figure out where things in the scope came from. And so it's just a terrible feature that nobody should be using. But
you can do it.
Like
you can do it in current ES modules, but you have to. It doesn't dump it into the namespace, so you can import star as foo
Right.
and then use like the bucket of things off of foo, which is cool.
Right. So that dumps it into one property that is named
Right, yeah.
at the top.
Yeah, it's totally
that's
different.
Totally reasonable.
Yeah.
It's totally different, but it's still like I know in some systems like Java, whenever you import star versus import something specific, your runtime gets a lot bigger because you have to actually pull in all those things separate. They're separate files, all that kind of stuff. With JavaScript, it rarely matters. It's usually like a single file. It's rarely like someone re-exporting a bunch of stuff. So it ends up not changing anything.
The main problem with it is that, you have 3 import statements and they all say import star from somewhere. And one of them gets the bar property from foo. And then later in the code, it's just calling bar. And you're like, well, where the hell did bar come from? Like, I need to know what this does. I need to look up its docs. Like, there's just no way to figure this out. So they revised the spec. They made it's still pretty Pythonic, but it definitely started to use some of the new syntax coming down the pipe that was also in ES6, stuff like that. I don't know, were either of you involved in the spec process at that point, where it kind of came back on the table, and then Yehuda got involved to try and make it a bit more compatible with Node?
No, I wasn't. I popped in a little bit later.
Yeah, I mean, I followed the tweets about it.
Yeah, I'm usually, when it comes to syntax, I'm not a curmudgeon. I'm pretty open to new syntax. So I'm like, let's have the new syntax. Let's start hammering on it and using it to see what shakes out. So I'm all for, like, at the time I was all for the import, the export, all that stuff. So
right, and I think like the spec sat in a weird state for quite a while. So this was before a lot of new processes were put into place at TC39. So the spec kind of lingered with people poking at it. Nobody had really implemented it yet. Nobody was using it in the wild because this was kind of pre-Babel. So we didn't have kind of, people really experimenting with syntax on the bleeding edge like that. And I think most importantly, now there's a staging process where you kind of go through stage 0, stage 1, and at each stage there are some bars around how many implementations there need to be and how much input that they've gotten. But there's a couple specs in what we call ES6, which is really ES 2015, that predate that process. And one of those specs is the ES module spec. So it got finalized before there were really many implementations out there. And there were some big question marks around, like, the loader, for instance. Like the module loader is another spec in the W3C that is, even less worked on. So anyway, this was at the time that it got kind of ratified in ES 2015. There was a lot of people saying, this is going to be compatible with Node, because Yehuda had done a bunch of work looking at, how Node modules look and work kind of to spec, and how ES modules work, and let's make sure that they have feature parity. When Bradley started to really dig into this, though, Bradley Mack, and figure out how we might actually, implement this support, he started to run into a lot of kind of crazy edge cases and gotchas in how Node's module system not only works today and loads modules, but also how it can be kind of dynamically shifted and stuff like that. And these are not, we call them edge cases because you don't find them until you go way down this rabbit hole, but they affect something like 20 or 30% of the Node ecosystem. So it's important that these actually get fixed. And that's, I think, where you really got involved, JDD, right? Like, you started to work on another spec and looking at changes. So I think you can really dig into this here.
I got involved last year around May, June. I had seen a lot of the discussion about MJS pop up, and I didn't really like the idea of a new file extension, so I popped on.
Let's unwind that a little bit. So, like, why do you need a .mjs extension? Like, why can't it, like, in the browser you have this new script include, basically, that signals, hey, this is a new style module, not an old style JavaScript thing. But we don't have that in Node.
You have type equals module in the browser. In Node loads things based off of file extension. a .js file, a .json file, a .node are handled based on their extension, and then it defaults to .js. It falls back if it doesn't recognize the extension. So for Node, because the existing module system is common JS, there needs to be a way to distinguish quickly between your parse goals, if it's going to be common JS or if it's going to be a module, an ESM module. ESM and ESM, because they behave differently and there's different rules in place for them. One of the things is like your ECMAScript module is going to have implicit strict mode, and there's certain syntaxes that are allowed in one and not in the other. So that's why the extension is there.
Okay, and you didn't like the idea that there would be this new extension, .mjs.
To me, it's basically the problem is that all new facing proper JavaScript, proper like ECMAScript modules would require this new extension, and it introduced some other things too, where it was like, well, Node is not a vacuum, even versions of Node. So projects don't tend to just support one version of Node. There's usually 3 versions that you end up supporting. And so if this is introduced, you're still going to have a transpile step if you're going to want to support Node 9 or Node 8. And so then that leads to things like doubling your package size because you want to have your .mjs and your .js. But then that also leads to things like transpilation is not 100% accurate. So you get these weird edge cases that a bug will appear in your Node 9 code, but not your Node 10 code in the same package. And so I didn't like the gap there for that.
Yeah. I think there's an additional gotcha in the transpilations too, right? Where, as we've been working with TC39 to figure out what parts of the spec maybe need to shift or adjust in order to make our support work, we're finding things in the Babel transpilation today that make the module system behave slightly differently than the spec says. And so we're moving towards the spec, but we're actually kind of departing from the way that Babel works. So if you're just using transpilation, you may actually end up with a completely different behavior than what you actually wanted.
But my main nitpick was just on the parse detection or the detection of the goal. I didn't want to introduce a new file extension because that also carries over into the browser. I mean, you say the browser doesn't care what extension it is, but there's already blog posts that say, hey, just write all your code in .mjs, even for the browser. And I think it seems unnecessary, and it seems like there should be a way around that. And so I've been kicking around alternatives. So last year I introduced with Bradley a proposal called unambiguous JavaScript grammar, which is a way that says if your module has at least an import or an export, then you know that it is an ESM file instead of a common JS file or a script target because it has import or export. At the time, Node really wanted that to be mandated by the language. So they took it to the TC39 and said, hey, TC39, would you be interested in changing the language to mandate this? Basically saying that an ES module must have an import or export to make it unambiguous. The reason is that if you don't have an import or export, there's no way to determine if this is a script file or a common JS file or ESM because it could look like any of them. That happened to fall through, though, so they decided that no, they would not mandate that. And so because they couldn't get a language change, they went back to saying, well, since we can't know based on grammar, we're going to have to go back based on file extension. And so they went, at least right now, with that proposal.
So can you dig a bit more into the logic there? Like, why did they not go with this unambiguous grammar? Like, why didn't they say that?
Because they want assurances. One of the things is when you're refactoring your code, you might remove an import or you might remove an export and be in a state where you're a side effect only module, which means no import or export. And then if you do that, you've unintentionally changed your parse goal. So you'll go from implicit strict mode to not strict mode. Certain keywords will be available to you or not available to you. So it's a stumbling block, right? there needs to be intent there. So like in the browser, you say that something is a type equals module. It's very explicit. But with unambiguous, it requires it at a syntax level. And just having import or export, it's easy to slip out of that and accidentally go to a different parse goal, which is why there's other proposals now, a year later, that say, hey, you can have a new directive that's like use module, because that's an explicit opt-in to ESM and something that won't likely disappear when you're refactoring your code.
So that brings us through up to that spec. So what does the landscape look like now? Like, who has implemented ES modules? How have they implemented them? Like, Node is currently pursuing this both in standards and in an implementation, trying to make this work with MJS. What's the current status of the spec and the overall implementations in browsers and stuff like that?
So I believe Edge has experimental. I think Firefox and Chrome are both experimental as well, and then I believe it has shipped in Safari. So basically, all the major ones have it either experimental or shipped.
That means you have to like turn on a flag and about something or other.
Right, or have a preview build of the browser. Yep. So it's coming. It's right around the corner. It's super, super close. It's not something that's like a year out. It's something that is like months out.
So there's also the loader spec, right? Which is its own kind of thing. Have they also implemented the loader spec, and are they considering that more experimental somehow?
I honestly, I don't know anything about the loader spec. It is super fuzzy to me. I don't know who's following that. I'm over here on the syntax side.
Have you guys seen System.js? Check that out at all? Mm-hmm. So System.js does a lot of stuff with the loader, right? It's built with the ES module loader project. It's the ES module loader polyfill. It has the low level
So it's a polyfill of the loader.
Well, right. It uses that in order to do more, but it uses the minimal polyfill for the loader API, and then on top of that, it does other stuff. It's pretty cool. I was actually expecting it to catch on a little more because it kind of does a lot of like what JDD's doing now, with like crazy support for all different types of things. But I think it went a little too hard into trying to like create its own whole ecosystem, and I bet you that's probably what kind of got it. But it does a lot. It has a lot of loader override type things that like kind of get towards that. That's Guy Bedford's project, System.js. It's worth checking out. I don't know. I mean, it has 8,000 stars on GitHub, so it's not exactly hurting. But I've never used it, so I can't really talk too much about it. But I think it's roughly in this space.
I believe I've seen a couple projects use it. I know he's really into that loader space. So I like to find devs that are super passionate about a certain topic and kind of defer to them for it. So I mean, if he's in it and probably is into all of the spec and follows all of that stuff. So I would say if you have a question or something, feel free to ping him on it.
Yeah, it's a cool project. People should check it out. I had a blog post a long time ago, as we all did, about AMD versus CommonJS that I thought I'd find a spot to put in here, and it's not it's not super important, but like there was.
I remember that post. Yeah.
I think it was a good post. Still, it was like a response, I think, to some terrible Tom Dale post where it's like, "Give up, AMD, you've lost. No. Everyone else is dumb," which is interesting because I'm pretty sure a lot of Ember uses AMD under the covers.
I was going to just say that Ember does use AMD.
Yeah, so I think maybe he read my blog post, which was just that like I don't care what you author in. Like authoring has like if you're gonna compile, that's fine. But if we're like defining a module spec that just has to work everywhere for everyone in all cases, then AMD is the superset. Like if you write synchronous like require statements and you want to use Browserify to compile it down to AMD, and then everything will be interoperable whether you use AMD or you use the thing that needs to compile to AMD. But like the whole point of it was like why like the standard that we all choose needs to be usable on the web without Node.js, right? Like you shouldn't need a server step in order to like use the default module specification. But everyone's going to compile. It's just right now everyone compiles, like even to this day, like Browserify compiles down to a function that's wrapped in functions with keys, and then Webpack uses like these IDs that throw everything onto an object. And like I feel like we could have kind of like interoperable bytecode modules, or at least for a long time. Now we have ES6, whatever, and it'll be fixed.
There was even a build step for AMD, and that was RJS, the build optimizer.
Right, but that yeah, and so I don't care if you keep it. If you don't mind authoring in AMD, which I didn't, then you might as well write it, and you're going to build it. But like AMD worked without a builder. It was an optimization step. Or
I never understood those kinds of fights. Like if you like CommonJS, use CommonJS. If you like AMD, use AMD. If you're a library author, support both, and you'll get more users. So
yeah,
like
I understand you in BestieJS were a AMD or a UMD creator, right? We didn't talk about that either. But I would have been more of a fan of just like, instead of UMD needing to exist, why doesn't CommonJS just compile down to AMD? Like that was my, like, use whatever you want, and then everyone compiles down to AMD, including people who use AMD, and that would like solve everyone's problem. But
at what point do you compile it down though? Do you, like, if you write a reusable module, do you compile it down before you publish that module, or do you just publish that module in the regular kind of Node module system and expect that somebody, when they use it in the browser, is going to use it compiled through?
I think everyone, much like now, like you can't really ship ES6 or whatever, or a lot of times you can't. You have to kind of transpile that way. Everyone, no matter their build stack, can use it. So the idea is like your dist folder would have your AMD compiled. You write in CommonJS, and you compile everything down to AMD in your dist folder, along with your coffee script or whatever we were doing back then.
Yeah, I mean, I remember I'm like remembering my position during this weird fight with AMD, and like the reality was we had like 100, like just way too many modules in the Node ecosystem that were being used by like browser tools and being compiled out of the browser to say, okay, well, we're just going to not use the spec anymore for publishing kind of reusable components. And on the what does it get compiled to side when you use it on the browser, yeah, AMD made more sense for people to use, but also there was already a spec for ES modules. Like we knew that there was going to be a module spec in the browser at some point in time.
No.
No.
It was extremely early and not like, in no way was that a thing that anyone thought would happen anytime soon. And it didn't. It didn't happen for 5 more years.
Right.
And it still hasn't happened.
Right. I think the thing that nobody really saw coming was Babel taking off, and then frameworks being built as Babel toolchains like React. So at that point, right, like you can use these new standards and just have them compiled down to whatever. And like it's not even worth having an argument over what that's compiled down to, if it's CommonJS, like AMD or CommonJS or whatever, as long as there's a good source map.
I actually think it's still a little bit sad that like it will eventually not be true anymore. Like eventually modules will work in the browser without Node. But I think it is a bad thing, and was bad for the web or whatever. And like there are tons of bad things for the web, and it's fine. Everything's going to be fine. But I think it's a bad thing for the web that we let that happen to the point where, like, if you want to use JavaScript on the web, you also have to use Node. That became a rule, right? And that's great for Node, but bad, I think, for the web. Like we locked people into, you must use this server-side JavaScript thing in order to use this open platform that's completely different ecosystem.
So this is what I argue with, though. One, like referring to it as the server-side thing is a little bit disingenuous, because when you use it this way, you're actually using it as like a front-end compile step, and you're using it as like the way that you would use
on
Python or like but you don't call Python a server language when you use it to just like run a script on your local system, right?
Yeah,
like it's a system language.
No, sure, but I don't care. What I mean is that people already had Ruby build pipelines, right? Like
but they sucked. I mean, compared to what we have now.
I mean,
they
all
could
have got better in the same amount of time. If
they couldn't because the people that innovated, like people that have been innovating in these tool chains get to work in JavaScript, and that's the language that they know and love, and they're part of that same community. And the reason why we have much better tool chain, like Node is not a particularly great language for this, actually. Like I mean, you're doing everything from IO into callbacks is like not particularly good at this case. I mean,
your bias is showing, in my opinion. I think we can parse JavaScript modules in any language that we want.
But we weren't.
Write a parser. I mean, we were in Java for one thing, and two, like there were plenty of really fundamental, huge leaps in tooling that happened, like in Rails and in a lot of these things, like prior to any of this taking off. And to think that like those tools would have just stagnated because Node never existed to come save the day because everyone could type everything in JavaScript.
That's not what I'm saying.
That's exactly what you're saying.
What I'm saying is what I'm saying is that it's definitely revisionist history to say that it would have been better if we didn't have to use Node for these things, because what we get from having a tool chain that can take all of these different Node pieces and put them together, regardless of what language it's in, is more valuable than not having it. So we're going to move to the system anyway. And the reason that we moved to Node was because these people were able to innovate quicker in JavaScript. So like you were at it. I remember that you were here. So in 2011 at the first NodeConf in Portland, we had a panel. And we basically asked one of the questions of the panel was, what should you not use Node for? And everyone on the panel agreed, including Ryan Dahl, Isaacs, like everybody. I think Brendan Eich was even on it. Like you probably don't want to use this for system stuff, for what you use make scripts for and things like that. Like it's nice to have a synchronous flow when you do that stuff. Literally the thing that is maybe the major use case right now in Node. We were saying, no, it's probably not good for this. And at the time, Merrick was able to wrap half of all the modules in Node. So that tells you like the size of the ecosystem at the time that NPM hadn't grown to. But after that, there were so many things written in Node and so many things written in JavaScript that could be compiled down to the browser that it was like, oh, wow, we get to tap into this great ecosystem when we write this tooling. This is a much better language to do this in. And a bunch of people like stopped doing this stuff in Ruby and started doing it in Node. Like they found it better, even though it's not particularly a better language.
No, they found it required.
Required.
My problem isn't that
who made them do this?
My problem isn't that Node existed and offered these tools. My problem is that the default thing that we all chose required you to use this single language. Like we got away from being able to do anything in any other language because we standardized a tool, like a specific tool. So I'm not mad that Node existed, but I think Node should have compiled down to a common format that worked on the web versus having everyone need to switch their entire systems over rather than choose their tool based on their needs or whatever.
See, this is what I don't get.
The revisionist history is to say like, oh, well, the Rails tools aren't good now, and that's because everyone had to switch over. Like of course.
This has to though, because like every tool that takes a Node module in the Node format and puts it into something compiled for the browser has to have its own interpretation of the module system. It doesn't get to leverage Node's module system. So like that being Node's module system is really no different than it being in AMD as far as Ruby is concerned. If you're parsing that in Ruby and creating a Ruby toolchain around it, you don't get any particular benefit actually out of using Node. You still have to implement the entire module system, or at least enough of it to compile things down. Browserify doesn't like use Node's module system. It has to actually re-implement it.
I think that is a very simple way of thinking about that. Sure.
I think that these workflows won because they're better. Honestly,
I'm not saying that they aren't better.
I thought they won because I want to write in JavaScript. And so when the opportunity came to be able to do that and have system level access, be able to write files and load modules and reuse code, I jumped at it. Like that was a no-brainer for me to switch.
Yeah, so I think maybe both of you are misunderstanding me. I would have immediately used all of the Node stuff. Like, I think it is the best tool for the job, et cetera, but I think that it is explicitly anti-web to essentially say this is the new standard, even if it's not a real standard. Everyone said this is how everyone has to do it from now on, which required people running Node. And And I think the fact that Node was the standard for modules, and it did not work on the web without using Node was a step backwards before we took step forwards. And that's all I'm saying. I still would have used it.
How do you load AMD modules without any code to load the AMD module?
I mean, like AMD by default just works. Like it injects the script tag.
There's still a little loader. There's still a little loader there.
Like you have like the AMD runtime. There's even like a miniature one, like 2K or something, Almond I think it's called. And like whenever you like, it sets up the namespace for things to be able to require and define, and then it loads your script. And then whenever you require a new script, it is asynchronous, so it doesn't run the function until it loads the 3 scripts that you say are required to run this, and then those are then available inside of the function that eventually gets run. It works completely without any build, and I think that's a good default because it doesn't require people who just want to like build a website to learn Node whatsoever, or learn any server-side anything.
So you can also do this with any module in NPM. Like there's a thing called Browserify CDN, where you can just in a web browser say, oh yeah, just require this module, and you don't have to have a Node build pipeline. You don't need a build pipeline. Like you can just use it, and it's not super popular because guess what? Everybody has a build toolchain anyway.
No, it's not super popular because the only thing I can think of that's worse than requiring Node is requiring browserifycdn.com as the required thing to build web pages.
Oh wow.
Like that's not a solution to this problem generally. It is someone else doing the Node build pipeline for you. That still requires Node.
As a sidetrack though, there is an AMD loader for Node too. So that was kind of cool. You could use AMD syntax and have it work in Node as well if you required the loader.
AMD actually even worked in most simple synchronous cases with a small build step that didn't need any context of, like, you could do it with bash, like so you just need to add a line up top, a line up bottom, essentially wrap it in a require function, and then as long as you had essentially statically analyzable with regex require statements, it could then do a function.toString and then figure out what you're going to require and then not call your function until it asynchronously loaded those things. That was an alternate thing that most people didn't know about. But so you could actually author synchronously and then still ship async AMD with like a bash build step that just concatenated a line up top and up bottom. All I'm saying is that everything's fine, and I used the tools that were the best, but I still think it was anti-web, and we could have done better, and we should have done better. We should.
I don't agree that it's anti-web, but I will say that the recurring theme here is that the thing that is standardized and adopted is just more important than the thing with feature X. And that's like a recurring theme that we'll see in technology forever. That like the thing that everybody happens to be using, the thing that gets the most adoption at a certain point in time is what we end up standardizing to, even if it lacks, feature X.
I think that is the direct reason why websites are really slow on mobile devices today. Like Node is the reason. The fact that synchronous giant builds seriously, this fact that synchronous giant builds became the quick standard of just like take everything in your Node modules and build it into this giant object that you ship as a 4 gigabyte file at the beginning of your website synchronously. That's like the Node pattern.
I thought Alex Sexton was my co-host, not Alex Russell.
That's the problem. So like if we would have started with something that could do asynchronous loading, then I think we'd be in a much better place where people would only be loading things that they needed for any given page by default, because that's how it works.
I actually think that it's very valuable to not have to write a lot of your own code, and whoever is the best at creating reusable code and dependency networks that allow you to do a lot more while writing a lot less are going to win. And eventually that's going to turn into a bigger bundle, and like it doesn't really matter whoever won was going to be the best at creating this future problem.
No, I mean, like by default, if you asynchronously loaded packages, you could just say like nothing has to change. It's just when you hit this page, the new package loads. It is like it's a built-in kind of feature to the asynchronicity of the thing. Right now, you have to do like right now there's some cool stuff with like async await on top of imports that people are starting to glob onto for asynchronous imports, and those are cool. And like finally, we're back into a world where this is possible. And I think once that catches on to do like, hey, this is a different view on a different route and it has a bunch of different dependencies because it's my settings, then once people move like into this idea of sometimes I can asynchronously load like dependencies, then bundle sizes will immediately like if you cut your bundle size in half, like that's huge. Like just two separate parts of your app, that's insanely huge.
It's already making its way into build tools too. Like Webpack
Right.
now supports dynamic import syntax,
Right.
and should do that. Deliver part of the bundle up front and then part as needed. So.
I don't know. Like I'm somewhat skeptical of like our ability to cut up the application code this much to make a big difference for secondary and third loads, when if you have a service worker, it gets loaded after the first load anyway. And if you have a mechanism by which you can update it before they've requested the new code, like when you publish something, it gets downloaded by the user in the background before it's actually needed. That's always going to be much, much faster.
There are definitely parts of the solution to this problem, but you can never get around the fact that the first time that you go to a web page, it takes 10 seconds on a not brand new iPhone to like parse the JavaScript. You know, it's a real problem and it's not going away. And I think that our current build system is a direct child, and the cause of it is because we adopted a synchronous server side tool for doing web building, and
so
it worked
I
for
don't
a long
agree
time.
with that at all, but okay. I think we have to, at some point we have to move on now. All right, so Alex Russell is going to take a break, and then we're going to get Alex Sexton back for a minute.
All right.
And then when we come back, we can get into the project of the week.
This episode is brought to you by TopTal, a global network of top freelance software developers, designers, and finance experts. If you're looking for contract or freelance opportunities, apply to join TopTal to work with top clients like Airbnb, Artsy, Zendesk, and more. When you join TopTal, you'll be part of a global community of developers who have the freedom and flexibility to live where they want, travel, attend TopTal events all over the world, and more. And on the flip side, if you're looking to hire developers, designers, or finance experts, TopTal makes it super easy to find qualified talent to join your team. Head to TopTal.com, that's TOPTAL.com, and tell them Adam from the Changelog sent you. This episode of JS Party is brought to you by our friends at Sentry. Sentry is an open source error tracking application that shows you every crash in your stack as it happens. It gives you details to prioritize, identify, reproduce, and fix each issue. They also give you information to support your team so you can use that information to reach out to those affected. Head to changelog.com/Sentry. Start tracking your errors today for free. Get off the ground with their free plan. Once again, changelog.com/Sentry. Tell them we sent you. And now back to the show.
Let's dig in now to the project of the week. So, JD, you wrote a loader to, I believe this is to the universal spec, right, that you're working on?
Yes. So I'm as part of Lodash 5. So Lodash 5 is the thing I'm working on. It's going to be ES6 Plus only. And I did not want to have to transpile it back for Node 4 or 5 or whatever. And so I wanted there to be a loader for that. And so I had to create one. So I've created a work in progress. This has not been published yet. If you go to the repo, which is GitHub standard things, ESM, you'll see the ECMAScript module loader there. It is for Node 4+. It supports .js, .mjs. It supports dynamic imports. It supports the file protocol. It supports live bindings. It's going to be spec compliant by default, which means that things like unambiguous grammar are off by default, but you can opt into them. Things like carrying over some of the common JS goodies like dir name and file name require named exports of CommonJS modules. All of that can be opted into, but by default, it will follow the node behavior of what MJS and ESM is in Node 10, except it will be available for Node 4+. So that's what's nice about that, is that you can just ship one version of your code and it just works. The consumers of your package don't have to care about it either. They don't have to worry about if they're loading ESM or CommonJS. For them, things will just work. So it really it removes a compile step. It removes having to have dual packages. It allows you to support a range of node versions, and you can use import-export. So it's a win.
So I really got to ask you. So the usage here is you do require add std/esm, and then the import syntax in the language starts to work properly. So how the hell did you do that?
Okay, so
I'm looking at this going like, how would this ever work?
So and I need to add an example for common usage. What you would normally do is inside your package, you have an index.js. So your index.js can be basically 2 lines long. The first line is to require the standard ESM loader. The second line is to then require your ESM code. Usually module.exports equals require your whatever.mjs and then .default. So that's it. And then after that, all of your ESM code should just work. What we do is we tie into Node's module compiling and loading mechanism. And we can then parse the code, transpile it on the fly, cache it, and then load it. But the thing is because we're dealing with such a small subset of the language, we can do this in microseconds, so not even milliseconds, super fast. It's cached, so it's only done once for the lifetime of the unchanged file, which means that most of the time it will be comparable to CommonJS loads, and that's how we do it. It's a quick, speedy transpile. And then I selectively wrap the loader. So what we've been able to do is most of the time whenever you have a loader that you're overwriting, it's a global change, but that would be not good because you would have modules that all of a sudden start working that did not opt into it. So I've done a lot of work to ensure that only packages that are using the standard ESM loader get the behavior. I've also done it in a way to where you can support versions of the ESM loader. So one package can be using version 1, one package can be using version 2, and they're not going to conflict or stomp on each other.
That's impressive. That's really hard to do properly.
Yeah, so we've got that going. So the idea is that, again, the consumer should not have to worry about it. It's just a way for you as a package author to have your import-export with very little ceremony. You basically require it as a dependency, and then you have that small hook inside your index.js file to load in your ESM code, which is great because later on, if you decide to drop the loader and you only want to do Node 10 plus, then you just change the index.js file, and that's it. So I wanted it to be super lightweight. Now I like unambiguous module grammar. I don't necessarily want all my code to be .mjs. I like a lot of the node carryover stuff. So for me, I'll be configuring it with those options. But for everyone else, it will be standards and as spec compliant as possible by default. So which is great because if it's spec compliant by default, then you can take that same code that you're writing and loading in Node, and then you can take Babel and transform it back if you want to for like a website. Or you can browserify it or Webpack and bundle it, and it should just work. So having it be spec compliant by default is a pretty nice default.
Well, and to make Alex here very happy, it means that you can just use this in the browser without any tooling and without Node, right?
Well, yeah. So here's the
eventually, when we have raw ESM support.
Well, no. So Node. So ESM in Node will still have Node's module resolution lookup, I believe.
Oh, right,
so,
right.
Right. So that doesn't transfer over to the browser. I wish it did because that's super handy, but whatever.
It could with a loader override, I assume.
That is correct. You are right. So, but the good thing is that existing tools should continue to work. So this is something that you can opt into. It gives you enhanced support. So another thing I like is that with Node version 7 plus, it's like 99.9% ES6 compliant, right? It's just essentially missing like tail call and import export. So this import loader, this ESM loader, just adds that import export bit to the language. So it's not having to support a ton of crazy stuff. That's why it can also be super fast inside of its transformations. One of the first things I did was reach out to one of the Acorn devs to see if they could come up with a way to do a fast top-level parse. And sure enough, they were able to cook one up in like a day and a half. I then took that to a project called Reify, which is done by Ben Newman. And Reify is what my loader is based on. So then I started contributing to Reify, improving its load time, improving its parse time, adding support for gzipped modules and some other things. And then from there, am now able to fork and create the ESM loader. So it's been like a 4-month plus process on this.
That's it?
For me, yes. But so 4 months for me. But for Ben has been working on this project for over a year. So I'm leveraging the work and the experience, a project that has not only been worked on for a year, but it's being used by Meteor.js right now in production. So it gives me confidence that, wow, so this thing is not just like, it's more, there's some substance to it. It's not just all theory. This is something that is actually being used at a company. People depend on it. So I felt a little more confident taking that basing it as my approach to the problem as well. Sure. And to me, it's super simple. It's one function call, then after that, you get it. What's nice is, as you see based on the README, it works in the REPL, the Node REPL too, which is where you just require it, and then all of a sudden the syntax just works, import, export after that, which is super handy. So I dig that too. One of the things that I'm excited about that's non-standard is the support of gzipped modules. So you know the browser supports gzip compression for your resources, JavaScript, CSS, HTML. It seamlessly handles that. Node doesn't seamlessly handle that, loading those kinds of resources. Node has gzip support built in, but there's just not a loader mechanism for it. Because Lodash is depended on by a good chunk of the ecosystem, I get to see report after report about file size. And the current build tools, going back to like build tools having some issues, the current build tools don't show the minified gzipped size of something. They show the on-disk size of your Node modules package. And Lodash happens to ship its dev build in the Node package. So that means it's got all of its documentation and source code inlined. So it's a 4 megabyte on disk. Lodash 5 will be gzipped and will be less than 90 kilobytes on disk. So I've optimized it heavily there. And one of the secret sauces to that is loading gzipped files seamlessly. So to the end user, their code will just work. But instead of it loading a .js file, it's loading a .js.gz or .mjs.gz file.
I mean, so word of caution though, not everybody should do that, because if you have a lot of tiny gzip files, they end up being like really large actually, right? Like there's not a huge amount of benefit to that. And I imagine uncompressing it in real time can be kind of slow as well for them.
No, so actually, if you gzipped, so I did an experiment where I just gzipped my Node modules folder, Babel, after a while, your build tools and your build change, you'll have over a gigabyte inside your Node modules folder. So I gzipped it and I saved 500 megabytes out of the gate. And it turns out that I/O reading from disk is actually more expensive in many cases than inflating gzip through your CPU. So in many cases, small gzip files will actually load faster. Isaac of NPM, formerly Node, has also written a 3x faster gzip loader, which is what I'm also using. So it's super fast. I'll be using it for, like I said, for Lodash. I like that because Lodash is, you can, if you want to load the kitchen sink, it's 600 plus modules. So I'm using that as my benchmark for the ESM loader as well, seeing like how fast I can load 600 plus modules in Node with or without the gzip there. So I will say it's not a silver bullet, but for me, since most people have multiple versions of Lodash, 4 megabytes times 4 megabytes times 4 megabytes or plus 4 megabytes starts to add up. And eat into people's quotas for things like Azure Functions or AWS Lambdas or Electron apps and things like that. Like your Node modules folder tends to inflate and can have consequences. So it's nice to be able to have a way to zip that up.
That's a really good point.
Yeah. But yeah, it's opt-in though. I'll be using it. The actual ESM loader. So what this doesn't show is that the ESM loader will be a zero dependency package and will be under 30 or under 40 kilobytes. So the ESM loader is not only small, but zero dependency as well. So I wanted people to be able to feel like they can add this to their project without having it bloat it up. So I'm using Webpack to actually build optimize the loader. I'm using Zoftfully to compress it, and then using the built-in gzip support to load it up and execute it. And it actually runs on par with a non-gzipped version. But it goes from being over 240 kilobytes to just being under 40 kilobytes. So again, it'll be fast, it'll be small, a zero dependency package that you can just include. Lodash will be taking a dependency on it. I'm incorporating feedback from people like Syndrasaurus because he's massive in the ecosystem. And so I want him on board with the ESM loader as well. Yeah. The naming.
Is that based on his tweet that said, "I will never move to .mjs"? In the history.
Well, actually, I had been discussing this with him before that even. If you notice in his tweet, he says he might use the loader that I'm working on. So
nice.
He's been in the loop for a while. So I like even the name. One of the first things I did was look up a standard official looking name and get the namespace for that in the package for that. It's because I want it to feel official. I want it to be spec compliant. I want it to be easy to reach for and use. And that would be a userland solution to this whole like MJS, ESM compatibility issue that will crop up.
So Corbin in the chat is asking, just general kind of what's the SSD and CPU on what you're doing these benchmarks on?
Oh, good question. So I have it's the MacBook Pro Touch Bar laptop plugged in. Even unplugged, I get similar speeds unless I'm on low battery, and that's when CPU starts to kick in. I will say that it varies from project to project, but the cost to me isn't egregious, and in some cases is a benefit. So for me, the file size savings is the biggest win for the compressed file.
What are people's concern there? They're just on like a resource constrained device, like a Raspberry Pi or something.
Well, I also think like when you're comparing the trade-off of gzip, right, is that it's a lower file size, but then you have to take some CPU cycles to decompress it. And so if you have, it matters if you have a fast CPU versus a slow disk, or a slow disk versus a fast CPU, or if you just have a fast both, right?
Right.
On a MacBook, I mean, you do have an SSD, but you're also on top of the worst file system ever created by human beings. So,
but also, this is also a single time load for the lifetime of the application because Node caches the loaded modules as well. So what you're looking up is what you'll be concerned with is your startup cost. And that's something that you can weigh. For me, the benefit's pretty clear because most people, so I should also mention this, is that Lodash 5 will not have an index file, will not have a main monolithic include. Everything is cherry picked, which means that a common usage is for people to reach for about 5 or 6 of the 300 plus methods and just use 5 or 6. So for me, 5 or 6 small loads are nothing, right? And so I get to save over 3 megabytes in package download and have almost negligible impact on load. It's a win for me in that case.
So right now I actually end up pulling down the Lodash dot whatever method that I need from npm so that I get a smaller version. How is that going to change in Lodash 5 with this?
Oh, so that actually ends up being a larger version. I'm stopping the individually packaged methods like the Lodash.chunk package, because it turns out code can't be shared very well across those packages. Something that's nice about a single package that has a lot of submodules within it is that you can use build optimizations inside Webpack or Babel to alias and reduce functionality. And that's something that doesn't travel well across packages. So I would end up actually duplicating a lot of code in those individual packages. Something I'm doing with Lodash 5 is before it went give you all the functionality up front, and then you have to opt out of functionality, which means it created a bigger build by default. Lodash 5 is going in the opposite direction and giving you minimal functionality up front, and then there will be mechanisms for you to opt into more functionality. So you'll get smaller builds by default. So with that, I think that the need for individual packages will be reduced, and I can standardize folks on just using the single Lodash package and the build tools that around that, like the Webpack and Babel or whatever you need to optimize and enhance your package and bundle.
So in order to do this, are Rollup and Webpack going to have to become aware of your module system, or how did you get around that?
For the gzip files, they will have to become aware. I've already contributed the loader to Webpack, and it's part of their Webpack contrib. So it's already in Webpack. It's already been published for them. For the other ones, yeah, they'll have to. What's great is that it's about 2 lines of JavaScript to get it to work. It's really not complex because Node already has gzip support, has a zlib module. So it's like you read the file in as a buffer, you pass it to the gzip decompressor, and then you spit out the output. So it's super tiny. But yeah, they'll have to add that. And I think that with Lodash, it will get added. So I'm not super worried about that. There will be a time where like Webpack will have it, and others won't. But I use Webpack. It's the thing with momentum. So I went and targeted that first.
That's great. Alex, do you have any remaining questions before we move on to picks?
No, I think let's do some picks.
Yeah. This is all super compelling. All right, Alex, why don't you kick us off?
I am going to pick somewhat of an ecosystem of ideas, kind of. It's the Fantasyland specification. So at Stripe, we use some types, and then there's some people who are really into types, and they make me use them a little more than I like. But some things end up being really pretty and good. And there's kind of this specification for interoperability of common algebraic structures in JavaScript called Fantasyland. I think they're referring to the fact that if everyone used this, everything would be so much better, which is like maybe true.
Actually, I believe that they were naming that because someone had been poking fun at them in a Reddit thread, and they said you must be living in a fantasy land. Yeah. And then that's how the spec name came.
So I like it a lot, but I agree that it is a fantasy land. But they have just like a set, and we use some subset of these at Stripe as part of our stuff. But it's just like whenever you need either algebraic structure to handle errors and left map, right map, whatever type stuff. But then there's a kind of a community that wraps popular things. So for instance, there's a Lodash Fantasyland implementation that...
Oh, no way.
Yeah, so you can get that, or you can get Ramda Fantasyland as well, or like any of that different stuff that kind of like... it's not only is it typed, because there are like type defs for both TypeScript and flow type, but also it adds in these kind of algebraic structures for how things come back and how you use them and things, and it's cool. I think if you kind of start with it or use it for some like base core of your fetching code or something like that, like any sub ecosystem could completely use this and be pretty successful, even if you can't use it like across everything, because like other libraries don't necessarily use it. But
I tend to think for functional programming, a little goes a long way. I'm into a little bit in moderation is a good thing.
Yeah.
I am on the fence about this whole FP thing. I offer functional forms of Lodash modules called Lodash FP. It's built into the existing 4.0. And that has everything auto-curried, data last, immutable, all of that stuff, right? And I kind of see it in the same vein as like I supported AMD, and the fans of AMD were so gung ho and so supportive that they gave Lodash a boost, right, in terms of usage, and they were super loyal. And I see FP as kind of that same thing where it may not be as big of an audience, but they are very enthusiastic. The users of functional programming styles are very enthusiastic. They're super eager to help. So I'm trying to decide how to continue that with Lodash 5 too. Totally cool. Yeah.
Yeah, you should look into Fantasyland.
Yeah. It's actually the most requested feature on Lodash right now is a Fantasyland compliant version.
Well, cool.
Bet you didn't know that. Yeah, man. Totally close.
I did see that issue, but yeah.
Yeah.
All right. Alex, JDD, you got a pick for us?
I do have a pick. And it is for projects like Babel. I would say they're always looking for contributors to help. So there's projects that I see requesting for contributions and pull requests would be things like Mocha, Moment.js, Babel. If you're looking to get into open source and you're looking to kind of get your feet wet, they have open issues that are tagged for things like good time first contribution, documentation tweaks. Things like that are a good way to get into open source, and you're really going to be helping out the projects. So I would say like look to those, especially if you use them in your day job. Like if you use Babel, go contribute back to it. If you use Moment.js, which is awesome for dates, contribute back a little bit. It means the world to the contributors. I mean, they're just like everyone else. They're trying to find the time to work on projects. So having a helping hand, or even contributing like feedback to an issue or documentation is a big help. So check out Babel, Moment.js, and Mocha.
Yeah, the time may have passed, but for a long time, the best place to contribute were anything that TJ wrote and abandoned. Was in dire need of people to do easy fixes. So I guess Mocha still falls there. But
yeah, but I'm just like that means the world to people. Like help out. Lodash itself is in a pretty good stable state. I'm taking my time with version 5, so I'm coasting on that front. But on these other ones, these other projects, they could really use some help managing issues and pull requests and features.
Cool. All right, my pick is MapZen. If you've ever had like integrate a map with a website or app that you're using, you probably poked around with a few things that are terrible and then settled on Mapbox. And Mapbox definitely set like a great standard. They were better than everything else, but they get really pricey really fast if you kind of blow out the free tier. And also, I mean, I just have a bunch of code sitting around that I have to copy and paste in order to figure out how to do things. So the MapZen JavaScript API is just a little bit more evolved, a little bit easier to use. They've got a lot of they have a lot of the same kind of support and cool tools and everything, but it's just a bit easier. The ergonomics are a bit nicer and much more incremental pricing. So loving MapZen. That's it.
Cool.
All right. Thanks everybody for joining us. Thanks JDD for coming on for this episode.
Yeah. Thanks for having me.
Yeah, anytime. And with that, we're all done for the day. Thanks everybody.
Bye.
Bye.
All right, thank you for tuning in to JS Party this week. Thanks also to our sponsors, TopTal, Century, and Hired. Also, thanks to Fastly, our bandwidth partner. Head to fastly.com to learn more. We host everything we do on Linode servers. Head to linode.com/changelog. Check them out, support the show. This show is produced by myself, Adam Stakoviak, and edited by Jonathan Youngblood. And the awesome music you've been hearing is produced by the mysterious Breakmaster Cylinder. We do this show live every Friday at 3 p.m. U.S. Eastern, noon Pacific. So join us at changelog.com/live. Slack with us in real time. Head to changelog.com/community. We'll see you again next week. Thanks for listening.